Welcome to qnawire.
So here in this problem we are given this truss and we have to calculate the force in the member DE and each of the member located to the left side of the DE. That means we have to consider this side of the truss and we have to calculate the forces in this side of the member. Now for that we'll be first calculating the angle alpha and this angle beta. Now if you consider this triangle, by using this triangle we can say that tangent alpha would be equals to 6.72 divided by 10.54. So from here angle alpha comes out to be as nearly 32.52 degree. Now next I will be calculating this angle alpha. For that we can consider this triangle. So from here tangent beta would be equals to, this height is 6.72 divided by this total height. So this distance is 23.04. So from here the angle beta comes out to be as nearly 16.26 degrees. Now we have calculated angle alpha and beta. Now next we will be calculating the reactions AX, AY and HY. So for that we will be using the equilibrium condition. The first one is sigma Fx equals to 0 and the forces towards this direction will be taking positive and towards this direction will be taking negative. Similarly in y direction, forces towards in the vertical upward direction will be taking positive and in this direction will be taking negative, and the moment in the anti-clockwise direction will be taking positive and the moment in the clockwise direction will be taking negative. So now we'll be balancing the forces in the horizontal direction and we have only one force in the horizontal direction, that is the reaction force AX. So we have AX equals to 0. Now next we'll be calculating the value of AY. For that we can do one thing, we can take moment about point H. So sigma mh is equals to 0. Now the first one is this is AY times the perpendicular distance. This thing is 4 times 5.76, and since the force is making moment in the clockwise direction, so we have to take a negative sign, plus, so this is 400 pound times the perpendicular distance up to point H, so this is 4 times 5.76, and since the force is making the anti-clockwise direction moment, so we have to take a positive sign. Similarly, plus 800 times 3 multiplied with 5.76 feet plus 800 multiplied with 2 times, this is 2 times 5.76, then plus 800 times 5.76, and it is equals to 0. Now we're going to solve this and we'll get the value of AY as 1600 pound. Now next I will be considering the free body diagram of the joint A. So this is a free body diagram of the joint A, and the force in the member AC we have assumed to be in tensile in nature, and in the member AB we have assumed the force it is acting like this. That means the member would be in tension. But if the value comes out to be as negative after solving it, so our assumed direction would be wrong and the member would be in compression. So let's find the values of forces. So for that we can do we can take first equilibrium condition, that is sigma Fx equals to 0. We will be balancing the force in the x direction. So we have FAC cosine alpha plus FBC cosine beta is equals to 0. Now we can put the values. So FAC we have to find, and cosine alpha we know it is 32.52, so we can plug it here. This is cosine 32.52 plus FB, this is AB, this is FAB, so plus FAB we have to calculate times cosine beta. So beta we have 16.26 and it is equals to 0. So from here we'll get the relation between these forces FAC and FAB as FAC equals to minus 1.38 FAB. Now we can use second equilibrium condition, that is sigma Fy equals to 0. Now we can put the values, or we can balance the forces in the y direction. So we have minus FAC sine alpha minus FAB sine beta minus 400 plus 1600 equals to 0. We have followed this sign convention. So we have FAC, we know it is this much, so we can plug it here. This is minus and minus will become plus, so 1.38, and it's FAB sine alpha, and alpha we know it is 32.52 minus FAB we have to calculate, and sine beta we have 16.26 is equals to minus 1200. Now we're going to simplify this and we'll get the force FAB as negative 3616.79 pound. And since the value comes out to be as negative, that means our assumed direction in the force in the member AB was wrong, and it should be acting like this. That means the member would be in compression. So we can write this thing as force in member AB is equals to 3616.79 pound, and the member is in compression. So this is the force in the member AB. Now you can put the value of AB here to calculate the force in the member AC. So FAC would become negative, and this negative would become positive, and we'll get the answer in answer as positive, and we'll get 4115.91 pound. And since the value comes out to be as positive, that means our assumed direction is correct, and the member would be in tension. Now next I will be considering the free body diagram of the joint B. So this is the free body diagram of the joint B, and in the member AB the force would be acting like this because the member it is in compression, and in member BC we have assumed that the force is acting like this, and if the value comes out to be as negative, that means our assumed direction is wrong. Similarly in member BD we have assumed the force to be acting like this. Now the forces in this direction will be taking positive, and in this direction will be taking negative, and similarly in this direction will be taking positive. So we can balance the force in the y direction first. Sigma Fy equals to 0. So we'll be balancing the forces in the y direction. So minus FBC minus 800 pound cosine alpha, it's beta. We will take a beta, so beta is 16.26 and it equals to 0. So from here the force in the member BC comes out to be as negative 768 pound. Therefore our assumed direction is wrong. That means the force in the member BC would be acting like this. Or we can write that the force in the member BC is equals to 768 pound, and the member is in compression. Now next we will be balancing the force in the x direction. So we have sigma Fx equals to 0. So FBD plus this is 3616.79 pound plus 800, we will take the sine component, so sine 16.26 is equals to 0. So from here we'll get the value of the force in the member BD as nearly this is negative 3840 pound, and since the value comes out to be as negative, that means our assumed direction is wrong, and the member would be in compression. Force would be acting like this. Or we can write that force in the member BD is equals to 3840 pound, and the member is in compression. Now next I will be considering the free body diagram of the joint C. So this is the free body diagram of the joint C, and we know that the force in the member AC, the member was in tension, so force would be acting like this, and here it was acting like this. Now the member BC was in compression, that means the force at point C would be acting like this, and in member AB, sorry, this CD, we have assumed that the force is acting like this, and if the value comes out to be as negative, that means our assumed direction is wrong. Similarly, here also we are assuming like this. Now let us calculate the forces. For that, we'll be balancing the force in the y direction, so we have sigma Fy equals to 0. So minus FCE sine 32.52 degree plus 4115.91. We have to take the sine component of this, so sine 32.52 degree minus, this is 768 pound, and we have to take the cos component here, so cosine 16.26 is equals to 0. So from here we'll get the force in the member CE as 2742.9 pound, and since the value comes out to be as positive, that means our assumed direction is correct. Now next I will be balancing the force in the x direction, so we have sigma Fx equals to 0. So FCD minus 4115.91 pound, and we have to take the component in this direction, so cosine 32.52 degree plus 2742.9 pound times cosine 32.52 degree minus 768 pound times sine 16.26 degree, and that is equals to 0. So from here we'll get the force in the member CD as 1371.4 pound, and since the value comes out to be as positive, that means the member would be in tension and our assumed direction is correct, and here also it was in tension. Now next I will be considering the free body diagram of the joint E. So this is the free body diagram of the joint E, and here the force would be acting like this because the member was in tension, and here we are assuming that the member would be in tension and the force would be acting like this, and here it would be acting like this. If the value comes out to be as negative, so our assumed direction is wrong. Now we'll be balancing the force in the y direction, so sigma Fy equals to 0. So we have FDE cosine beta plus 2742.9 pound sine alpha is equals to 0. Now we can put the values. Alpha we know it is 32.2, so this is 32.52 degree, and that is equal to 0, and beta it was 16.26. So from here we'll get the force in the member DE as negative 1536 pound, and since the value comes out to be as negative, that means our assumed direction is wrong. The member would be in compression and the force would be acting like this. So this is the force in the member DE, 1536 pound, and the member is in compression. Now since we have to consider only the forces towards the left side of DE, so we have calculated all the forces. So I hope you have understood the problem. Thank you.